In this lesson, you are going to review what you learned in previous grades so you're ready for Unit 1. The first one is nth differences. You have already seen the second differences, which you use the y values and then you subtract it using the table of values. Now, to use the table of values is one method. There is another method which is much faster, and it uses the degree of the polynomial and the leading coefficient. The formula to find the nth differences is equal to a times n factorial. Now, a is the leading coefficient, which is the coefficient of the highest exponent of the polynomial, and n is the exponent, the highest exponent in the polynomial, and the factorial is the repeated multiplication of that degree. For instance, just to refresh your memory about factorial, for instance, 5 factorial is defined as 5 times 4 times 3 times 2 times 1. And if you multiply all these, you're going to get 5 times 4 is 20, times 3 is 60, times 2 is 120. Now, you can use any one of these methods to find the nth degree of the polynomial. In the first example, you have y is equal to x squared plus 3x plus 5. You're supposed to find the second differences. Remember that this polynomial is of degree 2 because of the 2 here. We are supposed to find the second differences using table of values or using the formula that we just saw. Let's use the table of values. Okay, so what we're going to do first, we're going to make a table of values, let's say for values 0, 1, 2, and 3, and 4. When x is 0, y is 5. When x is 1, y is 1 squared, which is 1, plus 3 times 1 is 3, plus 5, which is going to give you 8, 9. When x is 2, 2 exponent of 2 is 4, plus 3 times 2 is 6, plus 5 is 11, 15. When x is 3, 3 exponent 2 is 9, plus 3 times 3 is 9, plus 5 is 14, 23. When x is 4, 4 exponent 2 is 16, plus 4 times 3 is 12, plus 5 is going to give you 28, 33. Now the first differences is 9 minus 5 is 4, 15 minus 9 is 6, 23 minus 15 is 8, 33 minus 23 is 10. Obviously you can see that the first differences are not the same, so this is not linear. Now let's find the second differences. 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2. You can see the second differences are the same, so we know that this is a quadratic function. Now the second part of the example is asking us to find the second differences using the formula. Using the formula, we know that a is equal to 1, n is equal to 2. So from here I know that n factorial is 2 factorial, which is 2 times 1, which is 2. So our nth differences, or in this case is second differences, is a times n factorial, which is 1 times 2 factorial, which is going to be 2, which is exactly the same as using table of values. The next topic is the slope of the line. As you saw in grade 9, the slope of a line which goes through the 2 points A with the coordinate x1, y1, and point B, which is x sub 2 and y sub 2, is given by the formula slope is equal to y2 minus y1 over x2 minus x1, which you will see in this unit, this is also called rate of change. So this is how you find the slope passing through 2 points. Now, if you look at this ratio, you can see that the ratio is undefined when x2 and x1 are equal, because x2 minus x1 is going to give you 0, and then you have a fraction with the denominator equal to 0, which is undefined. This means that if x2 and x1 are equal to each other, then it means that the line is perpendicular and the slope does not exist. The next example that we are going to look at is to find the slope of a line that goes through 2 points 1 and 2 and 4 and 15. So we say the slope is equal to m, which is rate of change, which is equal to y2 15 minus y1 2 over x2, which is 4, minus x1, which is 1. So we get 15 minus 2 is going to give us 13. 4 minus 1 is going to give us 3. So the slope of this line is going to be 13 over 3. The next topic is the different forms of a line that can be represented. There were two forms that you learned previously. One was standard form, which was of the form of ax plus by plus c is equal to 0. This was called the standard form. A, b, and c are constants, real numbers. The other form was y equal mx plus b, which is called the slope y-intercept form. You should be able to convert one form to another one. In the first example, we are going to rewrite the equation minus 5y plus 2x is equal to 15 in slope y-intercept form. So the equation again is negative 5y plus 2x is equal to 15. Since I have to have the form in y equal mx plus b, I'm going to move 2x to the right and I change the sign, so it becomes negative 5y is negative 2x plus 15. Now I'm going to divide by negative 5. I get y is equal to negative over negative is positive, so 2 over 5x. Positive over negative is negative, so negative 15 over 5 is 3. So the slope y-intercept form is y equal 2 over 5x minus 3. The slope here is 2 over 5, so this is my slope, and the y-intercept is equal to negative 3. The next topic is expanding binomials. First of all, remember a binomial is a polynomial which is of two terms. For instance, in this case, in our example negative 2x plus 3, there are two terms, negative 2x and plus 3, so this is a binomial. Now, to do the expansion, we can either expand it by repeated multiplication, or we can use a very fast and elegant method which is called Pascal's triangle. Now the first method, which is the repeated multiplication, for instance, in the case of negative 2x plus 3 exponent 5, we are going to write the binomial 5 times, and then we are going to distribute the first binomial into the second one, and then the product is going to be distributed in the third one, and so forth. This is a cumbersome method and prone to mistakes. But the best method, which is very fast, is Pascal's triangle. First, let's talk about what exactly is a Pascal triangle. Pascal's triangle is a triangle of numbers. The numbers, they have a very specific form. They start with 1, then the next row is 1, 1. Then the next one is the sum of the two elements on top. And it always starts with 1 and ends with 1. Now the middle one is the sum of these two elements, which is 1 plus 1 is 2. The next one is 1, again, ends at 1. And the elements in between is the sum of the two elements on the top. So it becomes 2 plus 1 is 3, 2 plus 1, 3. Again, the next row, 1 ends at 1. And the middle terms are the sum of the two elements on top. So 1 plus 3 is 4, 3 plus 3 is 6, 1 plus 3 again is 4. And continuing this way, I can write the rest of Pascal triangle, and so forth. Now, the other thing you have to remember, the Pascal triangle, the top element is called row 0, the next one row 1, and so forth. When we are expanding a binomial like this one, the first thing we do look is the degree. The degree is 5. So this means I have to write the Pascal triangle and find the fifth row. Now this is row 0 here, row 1, 2, 3, 4, 5. So these are the coefficient of the elements of expansion. You can see that there are 2, 4, 6 elements here. So when I expand this binomial, I'm going to get 6 elements. The way we expand it is very simple. First, specify your first term in binomial. The first one is a, we call it a, is negative 2x, and the second term is plus 3 or just 3. When you expand it, the expansion goes like this. It's going to start with a exponent degree, which is 5. So it's going to be negative 2x exponent 5. Then it's going to be b exponent 0. So 3 exponent 0. And if you look at the sum of the degrees here, you can see that 5 plus 0 gives you 5, which is the original degree. So write the same thing beside it. Now it's going to be negative 2x exponent 1 less now, so 4. And this guy, since the sum has to be 5, so this is 1. Then it's going to be negative 2x exponent 3. Then it's going to be 3 exponent 2. Negative 2x exponent 2, 3 exponent 3, negative 2x exponent 1, 3 exponent 4, and the last one is negative 2x exponent 0 and 3 exponent 5. Now in between we need the coefficients. We start with the first one, which is 1, and put it here, and then plus the second one, which is 5, plus the next one, which is 10, plus 10 again, the next one, then 5, and then plus 1. So this is the expansion. Now go ahead and expand this one and see what exactly the values are. Now negative 2 exponent 5 is going to give us negative 32. 3 exponent 0 is 1. So here we get negative 32 x exponent 5. Now negative 2 exponent 4 is 16 times 3 is 48. 48 times 5 is going to give us 240. So this is going to give us plus 240 x exponent 4. The next one, negative 2 exponent 3 is negative 8 times 9 is negative 72 times 10 is negative 720 x exponent 3. The next one, negative 2 exponent 2 is 4 times 3 exponent 3 is 27. So 4 times 27 is going to give us 108. And then 108 times 10 is going to give us 180. So plus 108 times 10 is 1080 x exponent 2. The next one is negative 2 exponent 1 is negative 2 times 3 exponent 4 is going to give us a negative 162 times 5 is going to give us negative 810 x. And then the last one, negative 2x exponent 0 is 1 times 1 is 1. 3 exponent 5 is going to give us 243. So this is the expanded form of negative 2x plus 3 exponent 5. The next topic is factoring. If you remember, factoring was the opposite of expanding. Now, in factoring, there are steps that you have to follow. The first step, which is always has to be done for any type of factoring, is the common factor. This means look at all the coefficients and factor out the common denominator, and also look at all the variables and factor out the common variable. Now, when that one is done and there is nothing else to factor, you will look at the coefficient, the leading coefficient. If the leading coefficient of 1, then you try sum and product method. You will find two numbers that the product is C and the sum is B. If that one doesn't work, then you are going to use the method which is called decomposition. Now, to show some of these methods, let's try one example given here. The example that we have to do is to factor 2x exponent 4 plus 7x cubed plus 3x squared. The first method we're going to use is common factor. You can see that x squared is common between all three terms. So I'm going to factor out x squared. So the first one, I'm going to get 2x squared plus 7x plus 3. Now, inside the bracket, you can see that the leading coefficient is 2. So you cannot use sum and product. Now I'm going to use decomposition method. Decomposition method says find the product of A and C. So AC is equal to 2 times 3, which is 6. And B is 7. This means find two numbers with the products 6 and sum 7. Those two numbers are 6 and 1. So this means I can write the polynomial inside the bracket as the following. X squared, 2x squared. Instead of 7x, I write it as 6x plus 1x or x. Remember, I can even write it as 2x squared plus x plus 6x plus 3. It doesn't matter. The same thing, same method works. Now take the first two terms and the last two terms and factor out the common elements. Between 2x squared and 6x, I can see that 2x is common. So I can write this one as 2x. 2x squared over 2x gives me x plus 3 plus x plus 3. Now you can see that x plus 3 is common, so I can factor that one out, and I get x plus 3 times 2x plus 1. X plus 3 is common. When you factor these by x plus 3, you get 2x from here and 1, which is the coefficient here. Now I can drop these brackets and I get this is equal to x squared, x plus 3 times 2x plus 1. The next topic is factoring difference of nth power. For instance, a exponent n minus b exponent n can be factored in the form of a minus b times a exponent n minus 1 plus a exponent n minus 2 times b plus a exponent n minus 3b squared and so forth to b exponent n minus 1. One thing you have to remember is for each term, if you add the exponents of a and b, you will see that the sum becomes n minus 1, which is a good thing to remember when you are writing the expanded form. For example, let's do an example here which says expanding x plus h exponent n minus x minus n. You can see that we can take x plus h as a and x as b. So this becomes a plus b, which is x plus h minus x times a exponent n minus 1, which is x plus h exponent n minus 1 plus again a plus b, which is a is x plus h exponent n minus 2 times b, which is x plus x plus h, which is a exponent n minus 3 and b exponent 2, which is x exponent 2 plus another term x plus h exponent n minus 4 and b exponent 3, which is x exponent 3 plus dot 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 plus, then we're going to have x exponent x plus h exponent 1 b exponent, which is x exponent n minus 2. Remember the sum of the exponents, they add up, n minus 1 plus the last term is b exponent, which is x exponent n minus 1. So this, which is the difference of the nth power, can be expanded in this form. A simple form of what we did before, which is the difference of the nth power, is the difference of squares. A squared minus b squared is a minus b times a plus b. Now, to do one example, we are supposed to expand and simplify this product. If we assign square root of 3 times x plus h as a and square root of 3x as b, then this becomes a minus b times a plus b, which is a squared minus b squared. So a squared is square root of 3 times x plus h, which is going to become 3 times x plus h minus b squared. Square root of 3x squared is 3x, so minus 3x. If we simplify it, 3 times x is 3x, 3 times h is 3h minus 3x, so it's going to becomes 3h. The next thing that you need to remember is how to simplify rational expression. For example, in this problem, we have to simplify 1 over x plus h minus 1 over x over h. So we are going to find the common denominator between 1 over x plus h and 1 over x. Obviously it's x times x plus h. Now x times x plus h divided by x plus h is going to give us x, and x times x plus h divided by x gives us x plus h, so, and there is a negative here, so you get negative x, negative h. Now negative x and x cancel out, so you get negative h over x times x plus h over h. Now this one is the same as negative h over hx times x plus h. Now h is cancelled out, so you get negative 1 over x times x plus h. The next topic is function notation. One thing you have to know is that in this part we talked about the composite functions, and the next example just reviews some of these topics. For instance, given the function f of x is 2x cubed minus 7x squared plus 3, we are supposed to find the point negative 2 and f of negative 2, and then we have to expand and simplify f of 2 plus h minus f of 2 over h. So the first one, to find the point, we know the x value is negative 2. Now we have to find the y value, which is f of negative 2. F of negative 2, we are going to replace x with negative 2. So we get 2 times negative 2 cubed, negative 7, negative 2 squared, plus 3, which is negative 2 cubed is negative 8, times 2 is negative 16. Negative 2 squared is 4, times negative 7 is negative 28, plus 3. Now negative 16 minus 28 is negative 44, plus 3 is negative 41. So for part A, the answer is negative 2 and negative 41. Now we have to find f of 2 plus h minus f of 2 divided by h. Now for the second part, we have to find f of 2 plus h minus f of 2 over h. So this ratio becomes 2 times x cubed, which is 2 plus h cubed minus 7 2 plus h squared plus 3. This is f of 2 plus h minus f of 2 minus open bracket. Now we are going to substitute 2 for x. So 2 exponent 3 is 8 times 6. 8 times 2 is 16 minus 2 exponent 2 is 4 times 7 is 28 plus 3 divided by h. Now if you expand 2 plus h cubed, you get h cubed plus 6h squared plus 12h plus 8 minus 7 times 2 plus h squared is going to give you 4 plus h squared plus 4h plus 3 minus, now inside the bracket, 16 minus 28 is going to give us minus 12. Minus 12 plus 3 is minus 9. And there is a minus before it, so it's plus 9 divided by h. Now if you go ahead and simplify this one, we get 2h cubed plus 5h squared minus 4h over h. We can factor h out, so we get 2h squared plus 5h minus 4. The next topic, which is very important, is the domain and range of a function. To refresh your memory, the domain are all the valid points that the function can take on the x-axis or independent variable, and the range are all the valid points that y or the dependent variable can take based on the domain values. For instance, in this example, we are supposed to find the domain of the function square root of x plus square root of 9 minus x. The domain is the x values. Now we have to find the valid or the range of all the x values which makes the function valid. Under the square root has to be greater than or equal to 0, so the first square root, which is this one, x has to be greater than or equal to 0. This means on a number line, if this is 0, every value to the right of the origin. The second part of the function tells us that 9 minus x has to be greater than or equal to 0. If I move negative x to the right, I get x has to be less than or equal to 9. This means that if I draw the number line, and this is the origin, and this is 9, everything to the left of number 9 is the answer. The first part, which is this one, says everything to the right of 0 is the answer. So the valid points or the domain is everything between 0 and 9. So we say domain is x such that x in real numbers and x is less than or equal to 9, greater than or equal to 0. The next example is to find the range of y equal x squared minus 4 over x plus 2. First of all, we know that the denominator can't be 0, so we set x plus 2 is equal to 0. From here, we will find that x is equal to negative 2, so the domain is x such that x in real number and x cannot be equal to negative 2. Now we are going to simplify the fraction. The numerator is difference of squares, so I can write this one as x minus 2 times x plus 2 over x plus 2. Since x cannot be negative 2, I can safely simplify x plus 2, so I get y is equal to x minus 2. This is going to be a linear, and as we know, a linear function, the values, the range is equal to the real number, so I can write that r is y in r. And there is no value of y that we cannot assign here. So the range is all the real numbers. The next one is function interval notation. We use three methods. One is using brackets and square brackets. The only difference between these two is that when you use brackets, then it's not going to include the extreme points. Square bracket also include these extreme points. For instance, if I have an interval looking like this, this means that the values are between 1 and 5, but including 5 because of the square bracket, but not including 1 because of the bracket. You can also use inequality notation. For instance, for this example, I can write that, for instance, variable x is less than or equal to 5, but greater than 1. This is the inequality notation. And the number line for this example is, if this is 5 here and 1 is here, then we know that 1 is not included because of the open bracket here, so it's going to be whole here. And 5 is included, so it's going to be a filled circle. So this interval is represented in 3 different ways. One was interval notation, the other one is inequality notation, and this one was a number line notation. In the next example, we are supposed to represent -3, 5 in equality notation. In equality notation, it's going to be, let's say, x is less than or equal to 5, greater than -3. Again, we don't have equal sign here because this is an open bracket. And in the number line, if this is 5 and this is -3, we know that 5 is included, so I have a fill circle there. But here I have a circle which is not filled because -3 is not included. And then everything is between is included.